believe this is like episode 4. We're going to work with multiplying monomials with negative exponents. A strategy that we kind of do with negative exponents is we basically take the negative out with what we call a flip. So let's see how that actually ties into these examples. A monomial is just a term connected by multiplication. So we have this is a monomial because it's connected by multiplication. This is a monomial because it's connected by multiplication. Remember, the prefix mono just means one, so this means just a single term. So we're multiplying these two terms together. Now, since everything is multiplication, we're allowed to use the commutative property and change the order of things, so things can be moved around. The first thing I can do, though, is I like to take the negative out. So 11 is not raised to a negative exponent, but notice how this m is raised to a negative exponent. So to simplify this a little bit, we flip the m to the negative third to the bottom, and by doing so, that performs the operation of a flip. And that's what the negative kind of means to do, is just flip it. So it's going to flip to the bottom. Now the exponent is no longer negative. So on this next monomial, the 8 and the n to the 5th don't have any negative exponents, so they stay right where they are. So 8 times n to the 5th will be on the top. But that m to the negative 4 is going to flip down to the bottom as m to the 4th. And we've learned that to multiply fractions, it's simply really just straight across. So what I'm going to do is just write this as one fraction. 11 times 8 times n to the 5th. And then I have an m to the 3rd times an m to the 4th. So if we look at this problem, what we could do is multiply 11 times 8, which is 88. That n to the 5th would stay right where it is. But on the bottom, notice how we have 3 m's multiplied to 4 m's. Since that's all repeated multiplication, I can say that's m's to the 7th power. So m to the 7th power. So there's 3 of these, 4 of these. So repeated multiplication says there's 7 of those multiplied together. So I can use the rule of an exponent to represent m to the 3rd times the m to the 4th. So that just simply changes m to the 7th. And there's really nothing else to this problem. So that would be multiplying these two terms together. This next example, not a whole lot to do on the first term, but we do remember that anything to the 0 power is 1. So I can change x to the 0 to 1. So this changes to 4 times 1 times then y to the 3rd. And then here we have the 12 is not raised to the negative exponent, but notice that these two terms are, the x to the negative 4 and the y to the negative 3rd, those are both negative, so I'm going to flip those to the denominator. And again, we basically just multiply straight across with fractions. So on the top, I'm going to have 4 times 1, which is 4. And I'm going to put that 12 by the 4. And I have that y to the 3rd on the end. So I keep cleaning that up a little bit. Y to the 3rd, I'm just going to move it to the end, because usually we like to have the numbers first. And then on the bottom, we just have this x to the 4th and this y to the 3rd. So the way this plays out then, the 4 times 12 is going to become then 48. We recognize that these are the exact same thing on top and bottom. So anytime you have the exact same thing on the top and bottom of a fraction, it kind of divides out. So those y to the 3rds will actually divide out of the problem, and that leaves me then an x to the 4th. So it simplifies into 48 over x to the 4th. My next example, this monomial here, I have a negative exponent, so that's going to move to the bottom. So I'm going to have 9. The v squared stays on the top, but that u to the negative 6 moves down to the bottom. So that flips over, and when you flip it, it's no longer negative. Times then, the only thing that doesn't have negative exponent is the u. So the u stays on the top. But that 9 to the negative 1 moves that 9 down to the bottom. So 9 to the 1st power is just 9. And d to the negative 5th will now just become d to the 5th. So again, when you multiply fractions, you just multiply straight across. So I have a 9 v squared u. On the bottom I have a 9, I'm going to go ahead and put the number first, 9 and looks like I have a u to the 6th and b to the 5th. So it looks like to me is, in fraction language here, that the 9s will divide out. There's a u on the top and there's 6 u's on the bottom. So what tells me is that one of those u's will divide out. So I'm left with a u to the 5th on the bottom, because that u there is going to divide out a u there. That leaves me 5 u's on the bottom. Since there's 2 v's on the top and there's 5 v's on the bottom, I can actually divide out 2 of the v's, and I'm left with a v cubed on the bottom. Now I can't just leave this numerator alone. I use kind of a 1 as a placeholder there, because essentially when everything divides out, it just becomes a 1. So you leave the answer as then 1 over u to the 5th, v to the 3rd. And that would be simplified. Again, we don't want negative exponents in our final answers typically. So this problem here, I have 10a, nothing to really do there. That a to the 0 changes to a 1, so that's 5 times 1 times b to the 4th, times then. And I have b to the 0, so that's just going to change to 9 times 1. So what's the negative exponents in this one? So if I just come across here and do some multiplication, I know I have basically 10 times, well 5 times 1 is 5, so I'm just going to bring the 5 over. 9 times 1 is 9. Then I'm going to put the letters on the end, so there's an A, and then there's a B to the 4th. Well, 10 times 5 is 50. 50 times 9 is 450. So we end up with 450 A, B to the 4th as our final answer. So there's a little bit of insight of working with negative exponents. Stay tuned for another example.